Good morning. Good morning. Welcome again to a Swift module. Here we are talking about closures today. What are closures? Closures are blocks of code that can be passed around like variables. So they're known as first-class citizens. Okay. Other things closures could do, they could capture references of their surrounding context. Closures are also known as reference types, very similar to classes. We'll talk about classes later in a different module. So let's get to it. Let's talk about what closure syntax looks like. So here I could create a closure. I'll call it closure. I will annotate my closure, and we'll go over this code. So very similar to, say, a variable. That's why we call it a first-class citizen, because very similar to variables, where I could create a variable name, annotate this, and give it a name, Alex here. Very similar with closure syntax, I could do the same thing. So here I'm declaring a closure, call it closure, and it doesn't take in any arguments. It does not return any arguments. So this is very similar to our function here, right? Our function, that would be the function. So for example, we have a function, some function like that, right? So here, very similar. So closures are very similar to functions. Here I have my parameter list. Here I have my parameter list. Here I have my return arrow. Here I have my return type, okay? In our case here, we are not returning anything. I could just say return void, or I could just do this. It doesn't return anything. Or I could do return void explicitly. But here I am not returning anything. So here I need to specify this. Or I could also say void like this. But my closure does not return anything. So let's continue on. So this is the closure definition. If I option click on closure, our compiler will show us that it's a closure, doesn't take in any arguments, doesn't return anything. If I option click on my function, doesn't take in any arguments, doesn't return anything. If I was to return a value, it would be like this. Here I'm returning an integer. Closures also could return values. We'll come to that later. All right, so let's continue on. My closure as it stands, it doesn't have an initial value. Like here, I have an initial value of Alex, but my closure doesn't have an initial value. So how can we initialize a closure? Well, we have the equal sign, and whatever we want to assign it to is going to be to the right side. In our case here, our closure begins, the body of the closure begins with a curly bracket, ends with a curly bracket. Again, very similar to our function. The function body, starts with an open curly, ends with an open curly. Our closure body begins with an open curly, ends with an open curly. In our case, our closure doesn't return any value. Very similar to a function here. I could just say print inside function body. So since my closure here is not returning anything, I could simply just say print and give it some statement, say closure executed. Okay. As it stands, I haven't called my function. To call my function explicitly, I have to basically say some func like that. And this is going to call, because right now this here is a function definition, right? So this here, just to review, this is a function definition. It defines what the function is, but the function doesn't get executed until it's called on line 16. So here, this is the function call. Very similar with our closure. We define the closure on line 19. So here, this is the definition. But to call our closure, we have to, same sort of syntax. I'll call my closure like that. And it doesn't take in any arguments. So I just pass in an empty parameter list. And if I was to run my Mac OS application, I just press Command R. runs my app. If you're in Playgrounds, you could totally do this in Playgrounds. My Playgrounds was not working. It wasn't that stable today, so I'm using a command line application, a macOS command line application. So here we are executing. So it says closure executed. Okay. I think it's just Xcode in general today. Okay. We might have to move this over to REPL because my Xcode is currently not stable, unfortunately. Let me create a REPL environment and we will move over to REPL. Okay. We could probably work with it for a second, and if it's still acting up, I'll move over to REPL. So here we were able to execute our closure. We have closure executed. Let's keep going. So closures as function parameters, right? Again, we said we could pass closures around, very similar to variables. So here, let's go create a new closure. Okay, I'll definitely have to move over to REPL. So let us copy. Second, let's close this out. Okay. All right, so you could continue using Playgrounds. I'm assuming your Playgrounds is probably more stable than mine at this point, but that's all okay. This is very similar to Playgrounds. Here we are in REPL, and let me just run our code so we back in the same spot that we were. Okay, so here we are. I executed my closure and I need to call my closure, or not, in other words, yeah, let's call the closure. So closure and run this particular closure, and here it says closure executed, right? Because we executed the closure, and all what it does is print closure executed. Okay, let's continue on. Let's talk about closures as function parameters. And we'll also talk about trailing closure syntax and what that looks like. So here we'll create a function called greeting. And what does greeting take? Greeting takes in 2 arguments. The first argument is the name. And the second argument is a closure. In our case, I'll call the closure action. And let's go over what that looks like. So here I have a closure. It's called greeting. Greeting takes in 2 arguments or 2 parameters here. First parameter is a string. Second parameter is a closure, as we saw closure syntax here. This particular closure doesn't take in any arguments, doesn't return any values, okay? Now let's continue on inside our function body. We'll print the name of the person. We'll just say hello, and we'll use string interpolation, and we'll say hello name, whatever the person's name is. And lastly, we'll execute the closure action. So action is whatever the person wants to add to that particular function, right? We'll see what that looks like when they call greeting. So on the call side, when I'm calling greeting, I'll say greeting, I'll pass in an argument, Bob. Okay, so that's a function call, passes an argument, Bob. I also have a closure here. So since I have a closure here as my last argument or my last parameter in my function, I could simply use what's known as trailing closure syntax. Trailing closure syntax basically looks like this. I have an open curly followed by a closing curly bracket, and this is the closure basically. So this is action here, right? Action again doesn't take in any arguments, doesn't return anything. So I could now execute any block of code I want between the two curly brackets here. In my case, I could simply say print and say name has been printed. Okay. Again, this is a function call. It has two arguments. My first argument is a string Bob. My second argument is a closure, and I just use trailing closure syntax. So here, using trailing closure syntax. Okay, great. So now let me go ahead and run this REPL environment. And here I'll see hello Bob, hello Bob. And my trailing closure syntax, I simply printed name has been printed here. Okay, so what we saw here was closures as parameters. This is a parameter here. And we saw trailing closure syntax. On the call side, I used trailing closure syntax to execute any extra code I wanted. Great. Let's now go on to talk about closures as optional parameters, right? What does that look like? So here I'll create a function, call it action. Action takes in a title, a string, and it also takes in a closure. We'll just use the word closure again here. We could give it a more explicit name, but closure is fine. So it takes in again two arguments, right? But this time our closure is going to be optional, okay? So closure here will be optional. How do I make that optional? I put parens between the two parens here, and I put a question mark to indicate it's optional. Let me make sure this is 1, 2, one more bracket. And now I'll assign it a default value of nil, okay? So remember back when we spoke about functions, we spoke about default parameters. So here, this is a default parameter. It's set to nil, okay? So the user is up to the user if they want to use this closure or not, right? It's an optional parameter. In my function body, what am I going to say? I'll say print and put in a string here, the title of the action is, and whatever the title is here, okay? Whatever the person put the title as, okay? Now let me go ahead and call my action function, and I could pass in some title here. It's looking for a string, and here I could say learning about closures, okay? Just like that. Learning about closures, great. Now let me go ahead and run my code. And here I'm seeing in my console, It says the title of the action is learning about closures. I pass in this argument here, it printed here, and again, the closure is optional. Earlier with our greeting function, the closure was required. I had to put in this, this block of code here. If I remove this, we'll get a compiler error, right? Missing argument for parameter action in call, okay? Because this is required. It's not optional. This parameter is not optional. But in our case here, this parameter is optional. So it's up to us if we want to pass in a closure, a trailing closure or not. Here, if I want to pass in a trailing closure, I can, and say action is complete, for example. I could say action is complete here. Action is complete. And now if I run my code, I'll see the title of the action is learning about closures. And did I print it out? Let me run it again. Oh, right. So here we haven't executed our closure. So here it's optional. So I simply need to say closure, call my closure. And again, it's optional. And if I run this code again, I'll see action is complete, okay? So again, it's optional. If I do not have this block of code and I run my code, right, nothing happens because this is optional here, right? So even if it's executed, there's nothing to execute. But if I do pass in a block of code here and I execute the closure and I run the code, it will execute action is complete, okay? So you have two options. You can make your closure optional if you want the user to have a choice, or you can make it required, meaning the user has to implement this closure. Okay, great. Let's move on to escaping closures. Everything we've done so far, just for context, is known as not escaping or non-escaping closures. So when we started off with our closure here, action is a non-escaping closure here. Closure here is also non-escaping, okay? And now we'll see an explicit escaping closure and we'll define what it is. So first, let's define a class, call it Blackjack. Okay, what does Blackjack take? Blackjack takes, will declare a closure called game score. Game score basically will capture the score of the game. So here, let's just put in an integer. So here, this is the first time we'll see a closure capturing a value. So let's actually see what that is here. Game score captures an int value. Remember earlier when we spoke about closures capturing values? So here, capture references. So our game score will capture the value of whatever the score is for the Blackjack game, okay? So here we defined a closure, it's called game score. Our Blackjack will have an initializer. This initializer will basically take a game score, which is a closure. Okay. So again, here, our closure should be matching game score. Same, right? So it takes an argument, which is an int, doesn't return anything. Great. And next, we will set our game score self to the game score passed in, just like that. And we'll define one more function in our Blackjack. Let's say function, call it play. And what does play do? Well, play basically calls game score, and it passes a random integer. It passes a random integer. And this random integer will begin from, say, 18, including 21. Okay? So let's talk about what's happening here. So we declared a closure, or defined a closure. Called game score. Game score takes in an argument, an integer, and it doesn't return anything. So far, so good. We have an initializer here. It takes in a game score closure, sets itself to that game score passed in, and that's our function. Now, if we run this code, we'll get a compiler error here. Let's see what the compiler error says. It says error assigning non-escaping parameter game score to an escaping closure. So here, game score here is an escaping closure. So game score is an escaping closure. Why? If we store a closure, or if we use a closure, if we use a closure as a variable, in an object, we have to mark it at escaping. Right. We have to mark this closure at escaping because what happens? Our initializer initializes game score, it returns the result, but our game score hasn't been returned yet. It hasn't even been used yet. It will be used when we call play, right? When we call play, it will be used. So here we're using this closure game score as a storage mechanism. So we have to mark it at escaping. So right here, inside of our initializer parameter list, we have to mark this closure coming in as at escaping. So it matches. So at escaping closure, this one here, needs to match this at escaping. I can have a non-escaping closure and assign it to an escaping closure. Okay. So now if we run our code, everything compiles and we are happy. Now let's go ahead and test our blackjack. So we'll test it. Again, we have a class here, it's called blackjack. I'll create an instance of blackjack here. Blackjack, and this instance takes in one argument, which is a closure. So here I initialize it, right? It takes in one argument, which is a closure. Again, the rules of a closure, if it's the last argument in a function, you could use trailing closure syntax here, which we are using. And we have one argument, which is an integer. So here I could call my integer, I could give it some name. In my case, score is the argument. And the in keyword is needed here as well. So score is just a name. Like earlier, we had our closures, they had no arguments. So this closure had no arguments, right? This closure had no arguments, but this particular closure has an argument. So we have to also define the argument here. I'll give it a name, which is score. Score in closure, right? So now I could use this score whichever way I want. It doesn't return anything. So basically, if I run this code, we should be good. It should compile because there's no return, right? Again, our closure is defined as this. It's an int, doesn't return anything. But I could use my score. Whatever the score is here, again, closures capture values. So whatever the score is here that this game captured, I'll have access to it on line 59, okay? So whatever, again, whatever score that this game score captured here on line 55, I'll have access to it in my blackjack trailing closure here. So now I could simply print score. Score is whatever the score is. And this is going to be a random score from 18 to 21. Okay. So now let's go ahead and run our code. And hey, look at that. We got blackjack. Score is 21. Great. If I run the score, if I run my project again, we got 18 this time. Okay. So we were lucky the first time, this time around. Great. Let's keep going on here. So let's now talk about shorthand syntax and what that even means. Okay, so let's go ahead and define a new function. We'll call it operation. Operation itself takes in two arguments, A, which is an integer, and B, which is also an integer. And it takes in a third argument, which is, or third parameter, which is an action. And this time action takes in multiple arguments, and it returns void, doesn't return anything. So here we have three parameters. The first two parameters are integers, and the third parameter is a closure. That closure takes in multiple arguments. Okay, great. And it doesn't return anything. How are we going to use operation? Well, we'll simply print num times num. Actually, we're not printing num times num. What we want to do here, we want to use action to capture what num times num is. The only thing action needs to take into arguments. So if I run my code right now, it will error out because here it says that missing argument for parameter 1 in call. So this guy misses arguments. So if I put in A, right, it still needs one more argument, right? Missing argument for parameter 2, right? Takes 2 arguments. So here I pass in A and B, right? So that closure as it lies right now doesn't do much. It just captures A and B. I could actually pass A and A. It won't care, right? If I run this code, right? It doesn't really care because all what it cares about, I need to get 2 integers, okay? So here we pass A and B, we capture those 2 values. So here, action is capturing value A and value B. Okay, so that's what's happening here so far. Great, now let us go ahead and use or call our operation. So if I call operation, I need to pass it arguments. I'll pass it A and B. In that case, I'll pass it 5 and I'll pass it 4. So far, so good. We also have a third argument we have to pass in here, which is the closure. And again, this is a closure, so I could use trailing closure syntax here. So using trailing closure syntax. Okay, our closure takes in 2 arguments. So I could just give them names, like call it value 1, comma, value 2 in, right? And now it doesn't return anything. So it's up to me to execute whatever command I want. In my case, I'll just print, I'll say, add in values together equals, I just add the 2 together. So here we have value 1 plus value 2. And I will go ahead and run my REPL. So here we'll see adding values together equals 9, right? So if we have 5 plus 4, it equals to 9. Okay, so here we had a longer form way of printing this out. And now let's talk about shorthand syntax. What does that look like? So here with shorthand syntax, I'll call my operation again. I'll pass in 2 arguments. Let's just pass in 10 and 5. And now I same trading closure syntax. And now instead of saying value 1 and value 2 in this, I'll just simply say, I could simply just say print, actually, because we want to print the values. And I'll say $0. So $0 here represents the first value. I have two arguments. So $0 represents the first value multiplied by the second value, which is $1. So this is shorthand syntax. So $0 is the first argument, $1, sorry, is the second argument. If I had a third argument, it would be $2. Okay? So this is how you use shorthand syntax with closures. $, followed by the value position. In that case, 0 position is value 1, 1 position is value 2 here. And now if I run my code, what do we have? 10 times 5, so we should see 50 being printed out. And here we see 50 being printed out, okay? So this here is using shorthand closure syntax. Awesome, great. Let us keep going on. So now we'll talk about closures with arguments. Well, we spoke about closures with arguments already. This is basically a closure here with arguments, but we'll just do one more just to drive it home. And here we'll say let is even. I'm defining a closure. This closure takes in an argument, an integer. It returns a Boolean to indicate if it is even or odd. I will give it an initializer. In my case here, I'll simply say return. I don't even need to say return because actually we'll talk about return. So I could say return $0 mod 2 should equal to 0, right? What does that mean? Again, the argument, in that case, we have one argument. If I take the mod operator of it, the remainder operator, it should be equal to 0 if this is even. If this is even, it should be equal to 0. If divided by 2, it should be equal to 0. So I could use this directly. I'll say print is even, and I'll pass it some number, 10. And this is just going to say true. Return some Boolean value. Run this. And here we see true. Okay? Because when I execute is even, again, it's a closure. It takes in one argument, which is an integer. It returns a Boolean value. So it just returns true. I could remove this return and run my code again. And I'll still get true. This is known as implicit return enclosures. So implicit return enclosures. Okay, so we don't need to specify return here. The compiler will infer that this returns a Boolean value because this equates to a Boolean value. It just returns that value. Great. Next, let's go to closures as return types, right? This gets a bit more interesting. Again, going back to when we spoke about closures as first-class citizens, they act the same way as constants and variables. We could return them from functions. We could pass them into functions, right? So here we'll actually return a closure. So let's define some closures. So we'll define add. Add takes 2 ints and it returns an int. We will give it an initializer, like what does it do? It basically, what does it do? It basically takes the first argument and it just adds it to the second argument, okay? That's basically what add does, right? Let's just copy this and create subtract. So subtract is very similar. Subtract, again, takes 2 ints, right? Two numbers you want to add together, and then whatever the value is, the result is, it's also an integer. So here we will basically say 0 minus 1. Again, two arguments. We define it as $0, $1. This is the first argument. This is the second argument. Okay, so here we are. We have our two closures, and we want to return. So let's create a function here. We'll call our function random operation. What does random operation do? Random operation just returns a closure. And that closure looks like this. Int returns an int, right? So we have our function here. It returns a data type, and that data type is a closure. The closure is very similar to our add and subtract closures. Two integers returns an int. Okay. Next, we'll create an array of operations, and that array has add and subtract. And simply we'll return operations dot random element. And this is an optional, so we'll just give it a default of add. So we'll just basically get one of those closures, return it. Okay, so that's basically our function. Let's just run this, make sure we have no errors. We are good. So now let's go ahead and call our random operation. So random operation just returns a closure. This is what we're talking about, closures as return types. This is a closure as a return type. So now I will say operation, and let me get a random operation. So random operation doesn't take in any arguments, but it returns a closure. So this operation here is a closure, okay? Now, my closure, I could use it like a function. So this operation here, operation is a closure. And what does it look like? It looks like this, right? Takes in two arguments, returns an integer. So now I could simply say print operation and pass it to integers. In that case, I'll pass it 5 and 8, for example. So here I pass it 5 and 8. Operation, it could be add or it could be subtract. We don't know. It's going to be random. So now if I run my code and I have -3. So let's guess what it is. It's subtract. It returns subtract this time. Okay. 5 minus 8 is -3. If we run the code again, let's see if we get add this time. We still get minus. We'll do it one more time. And we got 13. This time it added them together. Okay. So again, just to review, we defined two closures, add and subtract. They both are identical in their signatures, but their definition, their initializations are different. Their bodies are different. What they do is different. One adds the two operands together and the other one subtracts. And we have our function. Our function here returns a closure. Doesn't really matter. It doesn't care what the inside of the operations are, but all it cares about is the arguments. In that case, it returns to ints, or it takes into ints rather, and it returns an integer. So that's what add does, that's what subtract does. And now we could use it, get a random operation, and execute the operation here on line 91. Great. So we saw a lot of closures already. Now let's take a look at some built-in closures as we come down here to the close of this. So map is very popular. What does map do? Map transforms, basically. Map transforms elements in a collection. We could best see that as an example. So here, I'll just create an array. So just say map array, 1, 2, 3, 4. Okay, and now I'll just say map results. And what we want to do basically is, actually, let's just call this square results. So square results, basically what I want to happen is go through each element. Again, transforms each element, transforms each element in a collection, and returns the resulting array. That's what map does. So each element, we have 4 elements here, is going to go through each element, do a transformation, and return the result. The transformation is up to you what you want to do. In our case here with map, we will call our map array, and we'll say that map will use trailing closure syntax, which is the easiest way to do this as far as readability and all that. So here we'll use trailing closure syntax that we've seen, because map takes in an argument, which is a closure. So here we just use trailing closure syntax. Think back to our early examples here, where, for example, we had is even takes in a closure, right? Actually, let's go to the function. We have a function here. Let's go to our initializer, that's fine. Our initializer here takes a closure, it's a function. We call Blackjack, we just use trailing closure syntax. So same as map, we'll just use trailing closure syntax, and what we execute inside the body is up to us as far as the logic. But keep in mind, we have to pass in one argument. Map takes one argument. So if I call our function right now, I'll get an error because it says context type for closure argument list expects one argument. Map takes one argument. That argument is the element in the array. Each element represents that argument because it needs to go through each element to perform the transformation. In our case, we want to square each element. So we're just passing $0 times $0. I can say $1 because it doesn't take in 2 arguments. It just takes 1 argument. It's up to us what we want to do with this argument. In our case, we just want to multiply it by itself. So we'll just say times yourself by yourself. In our case now, I'll simply say print square results. And now I should get 14916, which I do get 14916 because it squared each one, returned the result, and we were able to print it out. Let's talk about filter. So here we'll say filter array, and we will create a very similar array here. Okay, what do we want to filter by? Filter, as the name implies, it just returns an array of filtered results based on a given predicate. When I say predicate, like whatever the condition is, a given condition, you could say condition, predicate. Cool, great. Let's go ahead and use it. So here I'll say let filtered results equal to my filtered array dot filter, which is the function, which is the closure, which is also known as a higher order function, since we're talking about built-in functions here. So just for us to recap here, I did mention higher order function. A higher order function is a function that takes another function or returns a function. Right? So that's basically what our map, filter, reduce, sorted, compact map does, right? They're higher order functions, they take functions or they return functions. Cool, great. So filter array, filter, and in our filter, again, we're using trailing closure syntax here. What we'll say, we'll basically say My argument, what do I want to filter it by? Any filter you have to do, it has to return a bool. In my case here, if I say where the argument is greater than 4, for example, that returns a bool, so that's fine. So think of filter looks like this closure, right? It takes in our case, an int, and it returns a bool. So if we were to think of what the closure filter looks like, this is what the closure looks like. It takes in an int, returns a bool, right? This is an int, returns a bool. This returns a Boolean value, okay? But filter works with any type. Filter could work with strings, any type, right? So for now, we're just working with ints, but think of it, if you have to think of any type, you could think of T as a generic type. But here we'll just keep to integers. And now if I go ahead and I print filtered results here, I should get back 5, 6, and 7, which I do. Because what did we say? Filter this array where the argument value is greater than 4. If we go through each, is 1 greater than 4? False. Is 2 greater than 4? False. Is 3 greater than 4? False. Is 4 greater than 4? False. Is 5 greater than 4? True. So that's 1. Is 6 greater than 4? True. That's 2. Is 7 greater than 4? True. That's 3. So that's 3 values returned. Okay. Next, let's go ahead and talk about reduce. So what does reduce do? Here I will say, I'll just create some values. We'll say 1, 2, and 10. It's fine. And what we want to do, basically, we want to add all those values together. Reduce is perfect for that. What does reduce do? Combines values given a closure. Okay. All right. Again, better done in an example. Here we'll say, let's just say sum. That's what we'll be doing. And we could say values dot reduce. So reduce takes in 2 arguments. The first argument is an initial value. In our case, we want to add. So we'll say 0 is the first argument. And the second argument is a closure. So if we were to do this long form, actually, let's just do the short form right now. Short form, the second argument is a closure. Here we just pass in plus, which is a closure, okay? It's a closure because it's a function very similar to our add. Think of our add here as a closure. So whatever we pass, so the add operator itself is a closure. So it's this whole definition there. Takes into ints, returns an int. This is very similar to this, okay? So now I basically have added all the values together, and now I could just print sum. And sum is 13, 10 plus 2, 12 plus 1, 13. Okay. Next, we have sorted, we have compact map, and cool. All right, so that's fine. Let's go through sorted. So what do we want to do? Let us create some names, or rather, let's just do characters. All right, we'll create a character array. Let's create a character array and give this some characters. So Z, A, and D. Okay, so we have an array. It's unsorted, and we want to go ahead and sort it. So let's just call this sorted characters, and we will, this is an array, we'll call sorted on it. Sorted itself is also, takes also a closure. So there's various sorted. There's sorted where you just pass in sorted and as without arguments, and it just sorts it ascending by default. But if you don't want to sort by default ascending, or you want to pass in your own sorting closure, you could do that using sorted. In our case, what we want to do, let's start off with the default ascending, for example. It takes in 2 arguments. So sorted takes in 2 arguments, $0, $1. Map takes in 1 argument, $0. Okay, cool. So now let's go ahead and print and see what the results are. So results of our sorted characters, and run this. So here we have ascending A, D, Z, okay? If we say we want it to be sorted descending, so this, let me just put some notes here. So less than sign is ascending order. And more than sign is descending order. Okay, so ascending means going up from small to large, from A to Z, ascending. Descending is the reverse. So if I was to flip this around like that, now it's going to go from Z down to A. Okay, Z down to A. So this is sorted, very powerful. The last built-in function which we'll do, there's many other built-in functions, but the last one we'll do is compact map. So with compact map is very, very useful, right? So we really, really want to be able to know and come to compact map when we want to. So compact map, let's just create, let's create grades, for example. So I have an array of grades. They're all strings. I have 89. I have 90. I have 90. I have 75. And I have 80. Great. So here I have an array of strings. This is what it looks like. This is an array of strings. Great. Now I want such that to only get valid grades, because right now 89 is valid, that's a number. 90 is valid, that's a number. 90 is not valid, that doesn't translate to a number. So what I mean by that, if I take the int initializer and I pass in a string, it will try to convert it to a number. If it's not a number, it will return nil. So basically what compact map could do or will do for us is first see if this is a valid number. If it is, return it as a valid value. If not, it's nil, don't add it to the resulting array. So let's go ahead and do so. So here we'll call this valid grades, and we will call grades. We'll call compact map on grades. Compact map also takes in a thread enclosure here. And what do we want to do? Well, each argument or each element is a string. So we want to take that string and we want to convert it to an int. So here we will say int, try to initialize it to a valid integer. This integer here that takes in some string like this is a fillable initializer, What does that mean? It returns an optional. So if it returns an optional, if it's nil, doesn't exist or wasn't able to be created. So if it wasn't able to create it, returns nil, our compact map won't return that result of nil. Basically, compact map removes nil values. That's basically what it does. So now if we print valid grades and run our app, we'll get back 89, 90, and 75 in the order in which it's valid, right? Because remember, arrays keep the order. So here 90 is not a valid number, 80 is not a valid number. So compact map, very, very, very powerful. Next, let's go to taking a look at chaining closures. So you could, all the closures we've seen so far, we could chain them together to get back some sort of result. So here, let's create an array. What's the array going to be? So we have 1, nil, and 5. All right, optional array of integers. We could use compact map, which we just saw on it. We could say compact map, remove all the nil values, which is what this does. So it goes through each value. If it's nil, doesn't return it. Now, we could also say, when you return those values for us, also map it. And what does map do here in our case? Let's just go ahead and square those numbers together. So let's just do multiply each number by itself. So the result should basically be 1 and 25. Let's go ahead and print result. And here we should get back 1 and 25. 1 times 1 is 1, 5 times 5 is 25. Nil gets rid of nil, doesn't exist. So if we run this, we'll get back 1 and 25. So here we're able to chain closures together. And you could keep chaining them, right? I could have an X dot here and say do something else, like reduce, right? Which we can do. We could say reduce here, and reduce, we'll start off with 0, and we'll say add those two numbers together. So now we should get back 26, right? Which we do get back 26. So now get rid of this, and now we just get back 26, right? So you could chain closures together. And sometimes what you do see as far as like readability, you see things like this where you basically keep them in order like that. So it's like compact map first, then map, then reduce, so on and so forth. Very powerful, very functional. Okay, lastly, let's do a simple exercise here. Let's rewrite filter. So this is a challenge we'll just do together. If you want to do the challenge, feel free to pause the video here and come back and watch the result after. Okay, so it's a nice little challenge to build upon what we just learned. And this challenge says rewrite the built-in filter function. So basically we just saw filter and we saw what filter did. Filter takes in an array, in our case, this array here, and it basically takes a closure and then returns a bool. So in our whole function, we'll have 2 arguments. One argument will be an array, and the other argument will be a closure. So 2 arguments. So go ahead and pause the video, and you could come back and complete the challenge. Okay, so here we have our function. We'll call it custom filter. That's fine. Custom filter is fine. And as we said, we'll have 2 arguments. The first one will be, let's just call it elements. And also let us make it generic. So it works with any type. Actually, first, let's make it not generic. Let's just make it an array of integers, and then we'll convert it. And then this returns a resulting array, because remember, filter just filters an array. And our second argument is, let's just call it filter. It's a closure. That closure takes in an int, and it returns a bool. Very similar to what we said earlier with what filter does, right? Returns a bool. Great. In our body, we'll start off, create an array. We'll call it filtered results, which is an array of ints, which is empty right now. And at the end, we'll return filtered results. Great. Next, we'll use a for loop, because remember, we have to go through each element. So this is the linear. So all those functions we've seen so far are linear, right? As far as runtime is concerned. So for element in elements, what do we want to do? Well, we want to check if we pass in filter, which is the closure. That closure takes in an argument, which is an integer element. So if this is true, whatever predicate gets executed here, we don't know. So if this is true, that means I want to add it to my resulting array. So if it's true, add it to the array. So filtered results dot append element. Okay, that's basically what filter is. So let's walk through the code. We have our empty array. We go through each element. We check if that particular element satisfies a given predicate or a given condition. If it's true, here, add it to the filtered results. And at the end, return filtered results. So let's go ahead and test this. So we'll create a numbers array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. And basically, we want to get back even numbers, right? This is our test. We'll call our custom filter. It takes in an array. We'll pass in numbers. Takes in a closure. We'll use trailing closure syntax. We'll use shorthand syntax as well. And we'll say $0, right? One argument, right? Just takes in one argument at a time. You see, that one argument is element. So for each element, check if it's even. We'll use the mod operator. We'll divide it by 2, and we'll get back the remainder. If it's 0, it's even. If it's not 0, it's not even. It's odd. So here, I'm done. I'll just go ahead and print even numbers. And now I should just get back even numbers. So let me run my code. And we get back even numbers, 2, 4, 6, 8, 10. So we were able to build the built-in, we were able to build our own filter based on the filter, the built-in filter function using a closure. So at the end of the day, this is just exercising our understanding of closures. So here we have a function that takes 2 arguments. One of those arguments is a closure. We're able to use the closure here on line 139, and that closure took in an int. Element here is an int. Okay, cool. If you were to convert this, like say I want to, let's see, say I want to get letter A, right? And here we have some characters. Let's get back all the A's here. Okay, I have A, I have B, I have A, I have A. So basically we want to get back 3 A's. Right now, if we were to use our filter function, let's just create this and then say characters, this, I need to type annotate this. Not really, but that's fine. Let's just type annotated character. It could just remain a string, that's fine. And now I'll just call my filter. So custom filter, and custom filter takes in characters. And basically what I want to do is a filter where this character equal to A. Well, that's not going to work right now, right? If we run this, it will tell us invalid. Well, first of all, this was existent before. Characters again, or more characters. And here, just call it more characters. And run the code again. So here we'll see cannot convert value of type character to expected argument of type int. Because right now our function only works with integers. But wouldn't it be cool where our function doesn't really care if it's ints or strings or doubles? Well, here comes generic, right? We haven't covered generics yet, but I could give us a quick glimpse at what generics could look like. So generics allow us to work, allows us to have our code basically flexible, right? Flexible as far as like I could use this function multiple ways on multiple data types. That's what generics allow us to do. Instead of writing the same custom filter 5 times or whichever amount of times you want to be able to use this, I could use a generic. So here I'll convert this function to a generic function. And then my generic type would just be called type T. I could call it anything. I could call it element, U. In our case, it's just going to be type T. So everything here is going to be converted to type T. Bool still exists because it has to, because I'm trying to see if it's true or false. But what I return here is also type T. Filtered results has to be type T. It could be strings, ins, so it's now generic. And we should be good here. So let's go ahead and run our code and see if we are also good. All right, great. The last thing I did not do was print. Let's just go ahead and print letter A or letter A's. We should have 3 here. And we do have 3, okay? So now our filter works on ins, works on strings as well. Could also work on doubles or anything else you throw at it, okay? As long as it's able to, as long as it's able to, there's no comparison, but it just returns true or false, so there's no constraint on that. So we are good, okay? We covered a lot today with closures, and there's a lot more to cover with closures. Closures is one of the most complex parts of the language. So knowing it is very, very important. So please, please, please review as much as you can with closures. They're great, right? So here we are. Let me just review from the top what we did today. So we started off by defining a closure. Here we just call this var closure, and closure takes in, this doesn't take in any arguments, doesn't return any arguments. And what else we did? We did a lot today. One second, let's go to the top. So here we did closure syntax definition. We did closures as function parameters and trading closure syntax. Actually, there's also multiple trading closures now in Swift as of Swift 5.3. So let me just put a note here. As of Swift 5.3, we now have multiple trading closures. Okay, so here we just have 1 trading closure, but we could have 3, 4, right? Up to us what we want to do. Closures as optional function parameters. Here I declared this. This happens a lot when you have like an alert controller, for example. You could pass in an action or not. We spoke about escaping closures, and escaping closures also appears in network requests, for example. Like if you're making a network call and you have a closure, that particular closure has to be at escaping because again, the function will return before the closure returns. So anytime that happens, you have to mark it at escaping. Shorthand syntax, we spoke about that. So we went long form, then we went shorthand, meaning $0. Next, we spoke about closures with arguments. Here, this closure has an argument, which is an int, also returns a type, which is a bool. We spoke about closures as return types. We had 2 closures here, add and subtract. We had a function that takes in, actually it doesn't take in any arguments, but returns a closure. So here we are able to randomize a closure, return it, and make an operation on it. So here we could return add or subtract. We looked at built-in closures in Swift, map, filter, reduce, sorted, compact map. We also chain closures together. And lastly, we ended up with a challenge. We write the built-in filter function. Cool. All right. As always, thanks for watching. See you next time.